Our next speaker is going to be Peter Wenner, and he has been with DEP since 2006, serving initially as a member of the Southwest District's Water Resource Assessment Team. In March of 2013, Pete became the statewide forensics coordinator for the DEP's Office of Emergency Response. Prior to hiring on with DEP, Pete worked at the USF College of Marine Science Center for Ocean Technology as part of the Underwater Mass Spectrometry Group, while working toward his MS in chemical oceanography. So welcome back to campus, Pete.
Good morning, everyone. Full disclosure, my response experience is nowhere near as extensive as the majority of the people who will be presenting to you today. And from this actually did occur down at the Port of Tampa not too long ago. The majority of our bread and butter in terms of responses are incidents such as this, or the daily diesel spill, as we say. If you see a semi disabled on the side of I-4 and there's a huge fuel spill in the middle of the road, that's what we respond to. We do have some responsibility regarding coastal incidents and oil spills. During Deepwater Horizon, as Tim had mentioned, he was the state on-sea coordinator out of Sector St. Pete Incident Command Center, which I think was housed here. Since that time, there hasn't been an event of a similar magnitude. And during that time as well, the role of DEP relative to those types of incidents has kind of morphed into something that's a little bit amorphous at this point. So I don't really know what our role would be in an incident similar to that, but hopefully we won't have to find out anytime soon. So what happened here actually was this is a water truck that was working at the Port of Tampa, and I can't remember if the driver actually drove off the seawall or just didn't put it in park and it rolled off, but luckily there was no release of any hazardous materials, oil or gas or diesel from this truck, and the recovery was successful. So, and it's a lot of, some of what I'll be talking about today is going to have to do with the practical aspects of response. One of the things that, I talk about quite often when I do PASWAPR, situational awareness. When you show up on a scene, take the time. If you have resources that allow you to make a determination about where you're going to go, what some of the risks will be, what's going to be there from an environmental standpoint. So familiarity, take the time to know your environment before you deploy. Pre-assessment, and that's and a lot of what I'll be talking about, in these ensuing slides, really looking at the resources, the digital technological resources, such as just been discussed, Tim, and with FMSAS and environmental sensitivity indexing. There's I've got slides on that, which will obviously be reiterative, but there are also a lot of other technological devices out there that can really assist in how you respond and putting together a response strategy before you even get on scene. So part of that is pre-assessment, baseline historical data. Plans, procedures, and SOPs, are they current? I mean, Tim had just talked, touched on that topic. Looking at the East Coast for the ESI index in 1996. A lot of that depends on, again, as you mentioned, funding, time, the ability to apply the time and resources necessary to keep everything current. Your network. Communication. During Deepwater Horizon, I actually was working with Stanford Research Institute. We were deploying an underwater mass spectrometer that we had developed at USF. And I don't know how this happened, but somehow I was appointed to be the liaison for the welding crew. And what was happening is that we were subcontracted through CSA. So they were converting marine service vessels. These were vessels that would actually transport supplies off to the rigs in the Northern Gulf into marine research vessels. So it's these things were being overhauled. We're cutting off, we're putting on A-frames, cutting railings and putting on winches. And it was a sad state of affairs. And I was appointed to be the welding liaison because I had the most experience with welding, and I don't weld. So these guys, these guys were geniuses, but they had this melange of broken Creole, Cajun with this patina of a Southern drawl. So I remember talking to one welder, he goes, go do this, put this here, weld this. I said, oh, great. At the end of that conversation, I realized I had no idea what he was talking about. And what occurred was exactly the opposite of what needed to occur. And the point being that when communication breaks down at that level, it gets filtered all the way up through the hierarchy of the command structure, and things go awry quickly. So that's one of the things like communication in an incident such as the ones that we were dealing with Deepwater Horizon. So the rest of this presentation will be looking at these technological applications that pretty much everyone in this room has probably had more experience with than I have, but these are the resources we have at hand that really make this job a lot easier than it used to be back in 25, 30 years ago. So look at FMSAS. This area contingency plan really is the Bible. I think everything that I list here, in terms of these applications, can be found in the ACP. Environmental, I'll just touch on this briefly because Tim did a very good and extensive job covering that. The IRMA, Environmental Response Management application. So GRP, NOAA's response guides and job age, which Mr. Bengio touched on as well. So again, these are all of the technological devices that we have at our disposal to really kind of hone in on a very specific response strategy in terms of protecting those resources that are most important. So FMSAS, again, layers of GIS data. One of the things I didn't realize, I looked into this, it's actually been, this really was innovative for its time. It was applied extensively during the 1993 Tampa Bay oil spill. And as a result of that, it was awarded, I think it was a government or a innovative technology in government, which was awarded by the Ford Foundation through the J.F. Kennedy School of Government at Harvard. And there are a couple of other awards that were assessed to it as well. So it's a very, very important piece of equipment that can be used during a response scenario. Okay, the area contingency plan. I've gone through this several times. Man, there's a lot of information in here. You start digging through that. It's pretty much everything you need for a response, from a coastal response standpoint, can be found in the ACP. It can be overwhelming because there's so much information in there. So it would, if you know that hey, I want to use the ESI to go, I want to, analyze this particular part of coastline, it's best to go right there. But if you're, if you're kind of in the weeds and don't know exactly where to go or what to do or what approach to take, you can get into the ACP and start drilling down. And pretty much anything that you need or you think will be helpful from the standpoint of a resource, can be found in the ACP. Again, I'm not going to go through this. Tim went through this at great length, but this is the few exercises that I've been on, spill response exercises. This has been an incredibly important tool because it not only from the standpoint of identifying those areas that have the most sensitive resources, from an environmental and biological standpoint, but it also helps you determine booming strategies. Sorry. So as Tim had mentioned, when you're looking at environmental coastal zones, you had an ES10, depending upon where the oil is going to be showing up based on the physical oceanographic model that's showing the plume disbursement, you can start developing your booming strategy. And I think, which application is it that has the booming strategy? Is that in the ESI as well?
That's in the geographic response strategy.
In the GRP. So you also have the GRP, you've got booming strategy. So using those two tools together, you come up with a pretty specific response plan to make sure that the resources that are most in danger can be protected right off. Irma, this was used during both Hurricane Irma and Michael. Again, a NOAA tool that allows the integration of static and real-time data. So this can be updated on a real-time basis so you have current information. I know that in Irma and Michael, as Tim had mentioned, we use the Collector app and Survey 123. And, that was an incredible step forward because as you're out in the field, You know, if you're identifying targets, you can get the information, you can make it, you've got all these other resources at hand, so you can make a pretty full description of what you're looking at, where the target is, what resources are at risk. Okay, and as Tim just mentioned, the geographic response plan. So if these grids actually represent specific areas of the coastline, obviously, you can go in and focus on one of these grids, click on it. Well, my slide disappeared. Anyway, it's the ESI, the booming strategy, so that grid will pop up in a separate plot, in a separate chart, and gives you all the information specific to that grid in terms for, you know, environmental resources that are at risk, booming strategies, you know, so it again allows you to really focus your response plan. NOAA job aids and resources, and again, Mr. Bengio discussed these, but there's a whole list of resources out there that really, in a way, at times it can be overwhelming. So it's really good to spend time trying to familiarize yourself with these resources, because you don't want to be trying to dig through all of this in the midst of an event that's already beginning to unfold. GNOME is a modeling tool. We also are lucky here in the Gulf Coast area that with the USF College of Marine Science, there are 2 Tampa Bay circulation models and another circulation model for the West Florida shelf. So that I know that in certain instances with research that I've done in the Bay, that I've made use of those models extensively. And again, it was Mr. Bengio mentioned the coordination between different resources and different organizations. You know, so I don't want to editorialize too far, but I know at some point it got a little contentious between USF and I know, Incident Command. But there were a lot of resources on the USF, on the academic side that were utilized and were of great assistance in terms of tracking where the potential Deepwater Horizon oil could go relative to the West Florida shelf. And so GNOME is a model that you can put in all of the physical variables, all the environmental variables, and start running that model to see where exactly, if you've got a release, where exactly that's going to end up over time. Cafe, this is an application that helps. It deals with, you can use chemical, so there's a wide variety of chemicals that you can input. Also looks at oil only, oil and dispersants, or dispersants only. And the 2 main focuses it has are looking at the longevity of a given chemical over time, given specific environmental factors that you can input into the model, and also the environmental impact, toxicity. So it takes toxicity information from toxicity tests, so your 24, 48, 96-hour toxicity tests, takes that information, integrates it into the model, so that you can get, depending upon where this release takes place, you can look at what sort of biota you have, what sort of fauna you have, and look at what the possible impacts over time could be as a result of that release. Cameo Chemicals, a database of hazardous chemicals, data sheets. This is similar. Everybody familiar with the Emergency Response Guide or the NIOSH Guide, right, where it just lists, you take chemicals and lists, the physical hazards. The Emergency Response Guide looks at it from emergency response as you're showing up on scene in the first few minutes of an incident. But CAFE offers pretty much the same sort of information. Cameo. Cameo also has a geo-based application that allows you to model releases, from an emergency response standpoint on the landward side. If you had a chlorine tanker, a tank car down the port of Tampa that was suddenly, for whatever reason, had a catastrophic breach, plume of chlorine gas, you can take, wind speed, what time of day it is, the temperature, all the climatological variables, put that into Cameo, and it'll show you where the plume is going to go, what the impact will be. So it allows you to, again, tailor your response to specific conditions that are prevailing at that point. Okay, MAP, so technological applications aid responders and this is really a huge step in this realm. I'm thinking also now of another Schwanman who works as a physical oceanographer here at USF, has been working with remote sensing for a number of years and has come up with algorithms for satellite-based technology that allows him to track, the best. He's really dialed in red tide blooms. So the other thing is, and I don't know if I think he's working on trying to develop an algorithm that also look at oil, releases, chemical releases. And I know he's also looking at nutrient analysis. So you've got, again, a number of technological resources out there that can assist with response. So all the identification of pollutant characteristics and their fate in water. Very, very important, selection of correct level of PPE. I know during Deepwater Horizon that was a big problem because a lot of people were heading out to the site of the release and weren't having proper, weren't attired in the proper PPE to begin with. And there was a specific protocol that was developed for that incident for PPE. Proper air monitoring equipment, very, very important in the instance of a inhalation hazard, release of an inhalation hazard. Development of boom deployment, collection, deflection strategies. It's mentioned that's part of the GRP. So all of these things really have come to the fore in the last 20 years or so by virtue of the development of, digital technology, now that we live in the computer age. And so these, again, just ways that these different technologies assist us now in beyond where we were, so again, 25, 30 years ago. So this is EPA emergency response air monitoring guidance type tables. So again, this allows us to make science-based decisions, right? There's, as Tim had mentioned, there's all the research that has been conducted relative to these types of incidents. It's been assimilated into a single document that gives you the information necessary for. So if you have benzene, depending upon these different types of products that are released, it gives you, a response strategy all the way down, as I mentioned, to the PPE that you would be attired in if you were responding to an incident that involved this type of compound under these specific conditions. The NIOSH guidance I mentioned before. Again, this one, NIOSH respiratory, this was developed specifically for the Deepwater Horizon response. Okay, so NIOSH is the National Institute of Occupational Safety and Health. This is actually the research end of the of OSHA. So a lot of the any changes that come to this, those types of response to a specific chemical, those come from NIOSH. They're constantly looking into this and developing and evolving different response protocols as a result. And again, and this speaks to the idea of communication, of trying to bring those entities, all the entities that are involved. And again, it's the importance of communication is directly proportional to the size and complexity of a given incident. So I can't exaggerate, can't overemphasize that. So that's, and I hit my 1 minute mark. So, and again, the Q&A I guess could wait until the panel discussion afterward. But yeah, if you ever see anything out of the roadways or that need a response or cleanup, this is our direct number. But again, the State Watch Office, the National Response Center would be the two entities to contact. Thank you.